Welcome to video 12 of Gamer to Game Developer Series 1, and this video is about blinking or teleportation. So we have two objectives, and that's to create the blink script and then set up a particle system for blinking. The code that we're going to write is really interesting, and I'd also like to thank a good friend of mine whose name is Peek, Jakrapopanerodvong from Thailand. And he helped me to debug the system of blinking and help me arrive at this system, which is much simpler than what I had originally developed. So basically how it's going to work is that we'll be setting up the illusion of teleportation. So the player isn't actually teleporting, it only looks like they are. So the player's blink script will access the character motor script, and it'll cause the player's speed to be increased a lot. So just for a fraction of the second. So while this is happening, the player will become invisible and invulnerable. So to all the other players, it really does look like that our player has teleported. So by performing blinking in this way, we avoid the problem of having to figure out, how to avoid the player from teleporting through floors, walls, or even uneven ground, which would be the case when we have terrain. So since the player is moving quickly, their collider will simply prevent them from moving through other colliders. And as I mentioned before, that when the player blinks, there'll be a particle effect that gets instantiated at their position where they start blinking, and this will happen across the network. And then there'll be another particle effect that gets instantiated at the position where they stop blinking. Alright, so our first step is going to be to create that blink script. The first thing that we'll do is to define two new inputs. So let's go to Edit, Project Settings, Input, and we'll replace the horizontal and vertical. So the first one, we're going to change it from the type joystick axis to a key or mouse button, and then we're going to change the name from horizontal to blink forward. And the positive button for this will be E. So I just put in E, press enter. Okay, and then now for the next one, for the vertical, we will change that type from joystick axis to key or mouse button. And we don't need it inverted anymore, it's not a joystick. And we'll change the name to blink back. And I'll change the positive button to Q. So Q will allow us to blink backwards. Okay, so that's our two buttons defined. Now let's create a new script. So create a new C# script, and we'll simply call it blink. And let's open it up in MonoDevelop. And for the summary, I'll just type out it's going to be a fairly long one. It'll describe what this script is for. So this script is attached to the player characters, and it allows them to teleport. So they aren't actually teleporting, so I'll write that. This script is attached to the player characters, and it allows them to teleport. I'll put that in quotations, so they're not actually teleporting, but it looks that way. They aren't actually teleporting, so we are simply making the players move at a really fast speed for a fraction of a second. So we are simply making the players move at a really fast speed for a fraction of a second. And we make them invisible and invulnerable for that duration. So, and we make them invisible and invulnerable. for that duration. So this gives a convincing teleport effect, and the player can't accidentally teleport through the floor, walls, etc. So this gives a convincing teleport effect, and the player can't accidentally teleport through the floor, walls, etc. And the next bit of commentary I'll put in is that this script accesses the character motor script to adjust the player's movement speed. So this script accesses the character motor script to adjust the player's movement speed. Okay, so now we can go on to our variables. And as usual, copy the variables start and end. Okay, so now let's start with our variables. So the first comment I'll put here, the inspector slot for the particle effect. The inspector slot for the particle effect. And that is public game object blink effect. The next comment here, the speed at which the player will move when teleporting. So the speed at which the player will move when teleporting. And that's going to be private float teleport speed is equal to 100. Then the next variable will be, we'll write the comment, the duration for which the player will move at the teleport speed. So the duration for which the player will move at the teleport speed. Private float active time is equal to 0.07 f. So you can see that it's just a fraction of a second that we're going to have it run for. Then now I'll have the comment, some quick references. And starting with private transform, my transform, private transform, camera head, private transform, player graphics, private game object, trigger, private character motor, motor script, and then we'll have another two variables. So we'll put here the comment that the start and end positions of the teleport. So this is used in determining where the teleport particle effects should be instantiated. The start and end positions of the teleport used in determining where the teleport particle effects should be instantiated. So private vector3 start position is equal to a new vector3. Private vector3 end position is equal to a new vector 3. Okay, so that's all of our variables. So now we can move over to the start function. If network view dot isMine is true, then my transform is equal to transform motor script is equal to my transform dot get component character motor. Oh, and you can see that my autocomplete is not working again. So I will just shut down monodevelop. So I'll just save what I've done so far. I'll just comment this out and then save it. And then close down monodevelop and reopen it again. Okay, and let's see, character motor. Okay, so it's working now. That's good. Player graphics is equal to my transform dot find child graphics. This is one of the child game objects attached to our players. If you recall, it's the graphics little game object. I'll just jump over to Unity and give us a reminder. So right here, so for example, on player blue, you can see that it has the graphics game object. And what we're going to do is we're just going to turn off the renderer while the player is teleporting. That way they become invisible. Okay, so find the graphics. Then trigger is equal to my transform dot find child trigger dot game object. Since trigger is a game object, it's of the type game object. Else, so outside this, that's complete now. So else enabled is equal to false. Okay, so that completes the start function. Next we can move over to the update function. So the first portion of our update function is going to cover forwards teleporting. So forwards teleporting. So if input dot get button down and the name of that button was blink forward, and also the cursor should be locked, and screen dot lock cursor is equal to true. So that way the player can't blink, you know, for example, if they're typing a message and they press E, then we don't want them to blink because of that. Alright, so the very first thing that we do when the player presses their blink forward button is that we should capture their starting blink position. So capture the blink starting position. So start position is equal to my transform dot position. Alright, then the next thing that we need to do is to find the camera head, because the blinking will happen in the direction the camera head is facing. Though that's only true when the player is in the air. When they're grounded, it'll still happen in the direction they're facing, but if the player is looking up while they're grounded in the character motor script, then they won't fly up into the air. They'll simply move forwards along the ground. To fly around anywhere in the air, the player first has to jump and then they can blink in any direction that they're looking at. Find the camera head. The blink will happen in the direction the camera head is facing. Though when the player is on the ground, so that's grounded in the character motor script, they will not travel through the air. They will not travel through there and will only move along the ground. So, and will only move along the ground. They must be in the air in order to move upwards or downwards. So camera head is equal to myTransform.findChild camera head Now that I think about it, it's not necessary to put this line here. We can just put this in the start function. So let's just grab it, pull it out, and place it in the start function. So camera head is equal to myTransform.findChild camera head. And I'll just change that comment slightly and get rid of that bit about finding the camera head. MotorScript.movement.velocity is equal to camera head dot forward times teleport speed. So that'll cause the player to move in the direction the camera head is facing at that high teleport speed. And what we're going to do is that we're going to make the player invisible and invulnerable for a moment, and then stop the teleport action and make them visible and vulnerable again. So we're going to use a function and a coroutine. So I'll write the comment, make the player invisible and invulnerable for a moment, and then stop the teleport action and make them visible and vulnerable again. So visible and vulnerable again. And we're going to use a function here. So, and I'm just going to just type out its name. Disable, we haven't obviously made it yet. Disable and start timer. Okay, and I'll just copy the name of it. So disable and start timer. And we'll set it up right now. So void, I'll paste that, disable and start timer. And the contents of our new function. So what we're going to do is to first disable the player's graphics. So disable the player's graphics so that they disappear for a moment. So player graphics dot renderer dot enabled is equal to false. Next, we'll disable the player's trigger game object. So their hit detection collider that's on them, we're just going to disable that game object so they can't be hit while blinking. So disable the player's trigger so that they can't be hit while blinking. So trigger dot active is equal to false. And then next we'll run a coroutine that will limit the player's high-speed movement to a fraction of a second. So run a coroutine that will limit the player's high-speed movement to a fraction of a second. And we need to now write that coroutine. So down here, write I enumerator, run for a moment, yield, return, new, wait for seconds. And that time to wait is active time. All right, next. Access the character motor script and bring the player to a halt. Access the character motor script and bring the player to a halt. So motor script dot movement dot velocity is equal to my transform dot forward times 0. Next, we'll enable the graphics so that the player can be seen again. So enable the graphics so that the player can be seen again. Player graphics dot renderer dot enabled is equal to true. Then we enable the trigger game object again. So enable the player's trigger so that they can be hit. Trigger dot active is equal to true. All right, and now we're going to capture the position at which the player has stopped moving. So since we've said here, stop their movement, we want this position as well because this is where the second particle effect should get instantiated. So capture the end position of blinking. End position let me just check what I called it. So private vector 3 end position, yes. So end position is equal to my transform dot position. And after doing that, now what we're going to do is to send out an RPC that causes the blink effect particle effect that we'll make later on to get instantiated at the start position and at the end position. So because this happens all so fast, we can just instantiate both of them at the same time. So right here, send out an RPC across the network. Send out an RPC across the network so that everyone sees the blink effect. So of course we need to write that RPC, but just before that, I should write up here, we should make use of the coroutine, or I might just forget to write this bit of code, which is start coroutine, and that is run for a moment. Okay, and now we'll write the RPC. So RPC void blink effect vector 3 start pos vector 3 end pos. So the start position, end position. And instantiate blink effect start pos end pos. Oh, sorry, start pos. And of course it requires a rotation. So quaternion dot identity. Then once again, instantiate blink effect end position, so end pos, and then quaternion dot identity. Okay. And now I can just write out our RPC right here. So that is network view dot RPC. The name of the RPC is blink effect. RPC mode.all, so send it to everyone. Start position, so we supply that RPC. It requires a start position and an end position. So start position and end position. Okay. So that's our RPC done. So we've written up a function that calls upon, it starts a coroutine, and the coroutine then fires off an RPC once it's finished all its processes. Okay, so that is blinking forwards. Now we need to blink backwards. So what we can do is to copy paste. We'll copy all of this for blinking forward. Paste it down below here. So and I'll write a new comment called backwards teleporting. And if input.get button down, so not blink forward anymore, that other input was blink back. I've just noticed here that I did not spell it correctly. So it's blink forward and blink back. And it probably wouldn't hurt to just go to Unity and make sure that I've spelt it correctly. So I'll go here, go to the edit, project settings, input. Okay, so it's blink forward, blink back. Okay. So now I'll head back. So yes, if the player presses their blink back button and the cursor is locked, then yes, we want to capture the starting position. And yes, we want them to blink in the direction, well, no, not in the direction it's facing. It is the direction opposite to what the camera head is facing. So the blink will happen in the direction opposite to what the camera head is facing. So when the player is on the ground, yes, that all looks all right. Now here we need to change this. So motor script dot movement dot velocity, at the moment it equals to camera head dot forward times teleport speed. So now we'll just put a minus sign. So minus camera head dot forward times teleport speed. So we're reversing, I guess, this vector here. So at first it was pointing in the forwards direction. By adding a negative sign, it's now been reversed. So now it's backwards. And yes, when the player is teleporting, we do want to run this disable and start timer function. So what does that do? It'll first of all disable the player's graphics. Yes, we want that. It'll disable the player's trigger game object. Yes, we want that. That'll make them invulnerable. It'll then run this coroutine to speed up the player it'll then run this coroutine to not speed up the player. We do that up here. to stop the player's high-speed movement. So after that time, active time, the player's speed is reset to 0, their graphics are enabled, their trigger game object is enabled, their end position is captured, and then the blink effect is instantiated at the starting and ending position. Alright, so that does look complete. So let's save our script. So I'll save that. Jump over to Unity. See that there are no errors. Yes, it looks like everything's okay. So that's good. That means we should be able to move on to the next step. Our next step is to implement the blink particle system. Alright, we'll set up our blink particle system. So what we'll do is, we'll first of all create a new empty game object. So game object, create empty, and I'll just reset it. And then I'll attach 3 particle components. So components, particles, and attach the ellipsoid particle emitter. Then components, particles, attach the particle animator. Once again, component, particles, and then attach the particle renderer. Okay, and then you can see there in the screen that I've got a bunch of purpley blobs appearing. So I'll just first of all replace the material. Well, I'll assign a material. So in the particle renderer, under element 0 for material, let's go through and find the default particle effect. There we go. So default particle. And that's it. So I'll zoom in on it. Let's zoom in over to it. Okay. So we can see what it looks like. Alright. So now let's start editing it. I'll just shift it up a bit. So I'll just move up its position so that we can see it a bit better. Alright, so now let's go through and change these settings. So the minimum size will stay at 0.1. The max size will become 0.3. The minimum energy will become 0.5. The max energy will become 1.5. The minimum emission will be 150. The maximum emission will be 250. Alright, so then the world velocity, let's have a look at that. I'll change the Y world velocity to 0.5. Okay, then next, let's have a look at local velocity. Yes, I'll leave all of those at 0. Next, let's check the round velocity, and I'll leave all of those at 0. I will leave the emitter velocity scale alone. Now coming to the tangent velocity, I'll change that. So X will become 1, Y will become 1, and so will Z become 1. Alright, and the angular velocity will get left alone, the round angular velocity will get left alone. I'll leave round rotation alone. Yes, we want it to simulate in world space, and I'll turn on one shot. Next, I'll come down to the ellipsoid and I'll leave it all at 1. Alright, so next we'll come down to the particle animator. And we probably don't need to change the colors, but I'll choose to set this one, the first one's alpha, to a higher value, as we don't really need our particle effects to really look like they're fading or are appearing, they start off in a faded sort of appearance. And I'll have a look at our world rotation axes, and yes, I need to change the Y, so it'll make it look a bit more like it's spinning, as you can see there, how it's changed now. So it looks like it sort of spins, and that's what I'm after. So then, Our local rotation axis will stay the same, and we won't have it grow. The round force will stay the same. There'll be no forces applied, and damping stays as it is. And yes, it will auto-destruct itself. Now coming down, do I need to change anything here? So it will remain as it is. We have the correct material. All right. So that's it for our particle effect, and it looks right. So now I'll create a new prefab. So I'll just deselect that. So under prefabs, I'll create prefab, and let's see, I can call this blink effect. So blink effect is the name of our prefab, and I'll drop our new empty game object into here. All right. And I can now delete this one, this game object, because we have created our blink effect prefab. Now the next thing to do is to assign it to the players. So to the player blue, I'll jump down to, well, first of all, I need to attach the script. So component scripts, I'll attach the blink script. And then to the blink script, I'll then just drop in this blink effect prefab. Now I'll do the same thing to the red player. I'll go component, scripts, blink, and then drop in the blink effect into that prefab slot. Now there's something else that I need to change as well. Now just scrolling up all the way up. We're going to change the mouse look script values. Well, not for this one. We'll change it for the camera heads. So at the moment, the player can only tilt their camera down 60 degrees down or 60 degrees up, which isn't quite steep enough. So when you're blinking and you really want to jump and you want to blink right above you or almost right above, then you need to be able to look up more or look less, or we'll look up at a higher, steeper angle. So I'll change minimum Y to -83, and I'll change maximum Y to 83. I can't set it to 90, because if we set it to 90, then later on when we have grass, that'll look very awkward. The grass will look like it's 2D flat on the ground, and it'll look like it's rotating. Well, that's a later thing. So that's why I'm just setting it to -83 and 83. Well, actually, no, the grass would disappear if it's too steep. And then going to the player blue, we'll do exactly the same. So -83. And 83 for the Y clamping values for the mouse look. All right, and I'll just check that those are all okay. Okay, it is. And I've attached the scripts, so I can save it. And let's go ahead and build and run. Okay, and I'll hit play here. I'll set up a server. Then I'll connect. And we only need one player to see the effect. I can join the red team. Alright, so we should be able to press E and Q. So yes, I press E and I teleport forward, as you can see. I can press Q and I'm teleporting backwards. So yeah, that's pretty neat. And you'll notice that we're only teleporting along the ground, and we can't teleport through the yellow cube no matter what we do, because our collider will simply prevent us from teleporting through it. And since we're moving at such a high velocity just for a moment, we sort of just, when we look at the cube, even though we're looking at it, we get stuck against it. But if we keep teleporting, it eventually just moves us out of the way. That's just the collider pushing us out of the way. So it's really good. So that way we don't even have to think about any issues of teleporting into something or falling through something. None of that. Our colliders simply do their job and save us all that hassle. Okay, so now we can jump in the air and teleport through the air. So yes, we can fly through the sky. We're high up above. We can teleport back downwards. We can use Q to teleport backwards up into the sky. We can use E to once again teleport forwards, down, so we're really high up at the moment. Yeah, you can see that we're really high up, which is really neat. And I have to say that this is easily my favorite topic in all of Series 1 is blinking, the teleportation script, because it's so simple and yet it's so effective. And it's really intuitive with how when we press E or Q while on the ground, we stay on the ground while we're teleporting and we can't actually move inside anything. So we actually get pushed out of the way, which is really good. And when we're in the sky, we can teleport in any direction, which is really neat as well. So you can pretty much fly anywhere. But we can't have that sort of thing. We can't have a game where people can just teleport forever and ever and ever. There needs to be some sort of a limit. So that's what we're going to introduce in the next video, is an energy bar and energy. So now our player, when they blink or they fire their blaster weapon, they'll use up energy, and energy will recharge over time. So that'll limit the number of times the player can hit their E or Q keys to blink, and also the number of shots that they can just keep firing off. So that's in the next video. So thank you for watching, and I hope you found this useful. See you in the next video.